Question says, find the zeros for the polynomial function and give the multiplicity of each. State whether the graph crosses the x-axis or does it touch the axis and turn around at the different zeros. As we can see, this polynomial is in the form of a constant times x minus what we would call c1 and x minus c2, where this factor is repeated 3 times. So it's raised to a power, which means that if I wanted to write it all out, we got x minus c2 times x minus c2 times x minus c2. Now the linear factors theorem says that if you have a polynomial of a certain degree, then that thing's going to be capable of being broken down into the same number of factors as the degree. So what is the degree of this polynomial? I can tell just by looking at it. The degree is going to be 4, which means his leading term would be x to the 4th. And that would be found by multiplying the x's all together. And so you would end up with an x to the 4 and then plus some other terms. What we're supposed to be able to do to find the zeros is set the thing equal to 0. And then we would break it up using the zero factor law. Well, first of all, we can divide the an out of the thing into the 0. So that goes away. And then what you end up having is these linear factors all multiplying to equal 0. Now the one factor is repeated, is 3 duplicates of the same thing. But when we set these equal to 0, we're supposed to find that x minus c1 is 0 or x minus c2 is 0. And I could write more of those, you know, but there's no point, right? It's all just the same equation. So I'm not going to bother writing it multiple times. But that's what they mean when they say multiplicity. This factor here has what we call a multiplicity of 1, whereas this guy has a multiplicity of 3. Okay, now what were the numbers that actually went with this? It was x minus 2 and x plus 4. So what we have for our problem is x minus 2 times x plus 4 times x plus 4 times x plus 4, all equaling 0. And so we make our separate equations according to the zero factor law, and then just solve them separately. So either x is 2 or x is negative 4. Okay, so these are called the zeros or the roots of the polynomial. And so they're going to be places where we have intercepts for this polynomial at 2 and negative 4. Now we want to look at the degree of the polynomial. So he's got 4 linear factors, which means by the linear factors theorem his degree is 4, which means, like I said, he's a x to the 4th plus some other terms. Now if your a is positive, then you're going to make a shape that opens upward like this. Okay, so this is if the leading term a is greater than 0. Okay, if our a is less than 0 though, then we're going to have the opposite. It'll open downward. And so we want to know what the end behavior of the polynomial is by looking at the coefficient and the degree. Alright, so let's check out his coefficient. It's a positive 5. We have a positive coefficient of a. Our a is 5. So we're going to have this case. Now, if you have an odd multiplicity for a root, so remember that this multiplicity was 1, which is odd, and this multiplicity was 3, which is also odd, then what we say is you're going to cross through the x-axis. Now the way you cross through could be that you just go straight through. Like this one here at 2 has a multiplicity of 1. When that happens, you just go straight through the x-axis. However, if you have a multiplicity of 2, what you end up doing is you end up touching the axis and then coming back. Or if you have any even multiplicity, you're just going to touch the axis and not go through it. You're going to come back. This guy having a multiplicity of 3 means he is going to go through the axis, but the way that he goes through will be by forming what the homework system calls a wiggle. They call it a wiggle when you go through the x-axis, but you don't go like straight through. So that's the kind of thing we would expect. He heads toward positive infinity. I'm talking about y equals positive infinity, by the way, on the left, and he heads toward positive infinity on the right. That's the end behavior, they call it. And so we're just supposed to be able to sketch a rudimentary possible graph for what he may look like. We go to Desmos and see if we can graph that. Let's just see what he looks like in reality. Okay, so there he is cutting through positive 2, but I didn't put all the factors in yet. So there we go. As you can see, he just cuts straight through x equals 2, but at -4 there is this cubic behavior. Y'all know what x cubed looks like, I assume, right? X cubed does that, has that wiggle that they're talking about.